Okay, so now we're going to talk about the derivative. Suppose that we start with a point, I'll just call it P, which is x f of x. And that's on the graph of f of x. Okay, so that's just some general point down here. We got some graph of f of x. And we've got the point P right here, which is just some general x value and the y value, which is f of x. And what we want to do is we want to find the line that is tangent to f of x at that point. Specifically, we'll be interested in the slope of this tangent line. So we've got our point, and we want the line here that's tangent to that. One way of thinking about this is just think about like maybe an ant or something that's crawling along this graph that's got a toothpick that's balanced on its back. And when the ant gets to this point right here, think about how that toothpick is going to look. It's going to be just something like this. It's going to be butted right up against that graph right there. Another way of thinking about this is that suppose that we got some kind of force here that is making this thing go up here, and all of a sudden, you know, like the force just lets go, and so the direction that the object is going at this exact point, it would just kind of keep going in that direction right there. That's the tangent line. And so what we're really going to be interested in here is the slope of this tangent line. So we're going to talk a little bit here about how do we derive this slope. All right. So let's say that we have 2 points. I'll call them P and Q. And we can find the slope of the line between 2 points. Remember, this is just an algebra formula. If I've got 2 points on a line, then I can just take the difference of y values over the difference of x values. Now, we're going to build up our points here in a special way. Suppose that we've got our point P right here. And remember, that's just got x, f of x as its coordinates. Suppose that we want our other point to be h units away. Here's our x value, and we're going to go h units over to get some other value here, x plus h. Like, for example, if x is equal to 2, and we want to go 3 units over from that, then this would just be 2 plus 3. This would be at the point 5 right here. Okay, so x, we're going over h units. We're at x of x plus h. And so if the x coordinate here is x plus h, we throw that into the function to get the y value. And so we have the coordinates x plus h, comma, f of x plus h. And that's our other point that we're calling Q. Now, if I've got these 2 points, I can draw the line between those, and I can find the slope of that. Now, don't get all mixed up here. I mean, x, f of x, x plus h, f of x plus h. If I knew exactly what the function was, and if I knew what my values of x was and my value of h, then these would all just be numbers up here. And I would be able to find that slope pretty easily. But we're going to call this line right here, we're going to call this the secant line. Okay, so when we have 2 points on the graph, and we draw the line between those 2 things, and then we go on to try and find the slope of that, we're calling that the secant line. Okay, so let's go ahead and see if we can write down a formula for that secant line. All right, we've got the coordinates x, f of x, and x plus h is the x coordinate here, and f of x plus h. So the secant line, the slope of the secant line, well, okay, just remember from algebra, y2 minus y1 over x2 minus x1. That's just the formula for the slope. So I'm going to let P be my x1, y1, and Q be my x2, y2. And so what I would get right here is I would get f of x plus h minus the y value down here, which is f of x, over the x coordinate here, which is x plus h, minus the x coordinate down here, which is just x. And it looks like what I end up with is I end up with f of x plus h minus f of x. And down here, I've got a couple of x's that cancel out, just leaving me with h. And I've got a formula that tells me the slope of the secant line. Now, admittedly, this is kind of a messy formula, but if I know what my x value is, and I know what h is, so I can find x plus h, then those are just going to be a couple of numbers that are thrown into the function up here, and then h is just whatever I decided h was going to be. And so this is something I should be able to find, you know, if I have my function defined, and if I know what my x and h are. So actually, it's going to be a fairly easy thing for us to go back and find the slope of that tangent line based on what I can find here with the secant line. Because all I have to do to get to my tangent line is I'm going to say, well, let's let h get smaller and smaller and smaller. In other words, let's bring this point right here closer and closer and closer over this way. And what that will do is that will make this point right here kind of slide along this graph. And eventually, if I get that point close enough over here, then what happens is that my line is going to be really, really close to that tangent line that I was looking for. And so that's what we're going to do. We're going to see what happens here when h gets smaller. When h gets smaller, I see that I've got these two points right here. Let's make it a little bit smaller so this comes over a little bit smaller, a little bit smaller. When h gets really small, you know, if I just go a little bit further, I actually end up right back here at that tangent line. Okay, I'm going to take a real quick look at this over in Desmos. I've programmed this so that we can kind of see this in action. Here's my point P. Here's my point Q. And Q is the point whose x-coordinate is h units away. I can see the tangent line for P over here. I can see the secant line. If I drag this point a little bit over here, closer and closer and closer, so that h is getting smaller and smaller and smaller, I see that eventually the secant line converges in and becomes the same as the tangent line. So the smaller h gets, the more the secant line approaches the tangent line. Now remember, we have an idea for what we mean when we say h gets smaller and smaller and smaller. Remember, that's just saying h is heading towards 0. It's a limit as h approaches 0. So if we think about the slope of the line that's going through the 2 points, that's the secant line, which is f of x plus h minus f of x over h. That's the slope of the secant line. If I take the limit of this as h approaches 0, then what happens is that we're ending up with the slope of the tangent line over here. So this is the slope of the tangent line. And we have a special name for this. This is a special thing. We call this the derivative. Okay, so the derivative of a function f of x is given by f prime of x. That's our notation. F prime of x is equal to the limit as h approaches 0 of f of x plus h minus f of x over h. Oh. Okay, so let's just kind of think about this for a second. I've got a function here, and let's just think about what this would look like for some different points on here. For example, here at this point right here, I'm going to call this, I don't know, I'll just call it x1. Well, x1, there's a point on the graph that has that coordinate. And if I think about what the tangent line looks like there, it looks like the tangent line would just be sort of straight across. That's right there at the top of that graph. So it looks like that tangent line would just be straight across right there. The slope of this tangent line is the thing that we are finding when we find a derivative. And so this would be f prime of x1. Whatever number that is, and whatever this function f prime turns out to be, that would tell me the slope at that point right there. And it looks to me like this would end up being 0. If we had another point, let's take a point like, I don't know, right about here. And let's call that x2. So there's the point on the graph. The tangent line looks like the tangent line would be something like this right here. And so we're thinking about the slope of that tangent line. When we go in here and we find this derivative and we plug this x2, whatever number that turns out to be, into that derivative, then we're ending up with the slope of this. That would just be f prime of x2. Okay, so remember, f prime of x represents the slope of the tangent line to the graph of f of x for each value of x. Okay. So let's look at an example of doing this. Now I'm going to go ahead and tell you ahead of time, hey, with this, we're going to do this in sort of a complicated way. And you know, it's going to be a little bit messy. There's going to be some algebra involved, but this isn't the way we're really going to do derivatives. This is so you can kind of see how all this stuff works here. All right, so we've got a function here. We've got f of x equals 2x squared plus 3. We want to find the derivative, f prime of x, and we want to interpret the quantity f prime of negative 1. Okay, so I'm just going to sort of rewrite my function. F of x is equal to 2x squared plus 3. And I know I want to find f prime of x. And f prime of x is equal to the limit as h approaches 0 of f of x plus h minus f of x all over h. That's our definition. And so let's see, let's just plug our stuff in here. F of x plus h, that would just be taking x plus h and putting it everywhere I see an x up here in my function. That would be 2 times x plus h squared plus 3. And now I'm going to subtract the original function, right? I'm going to subtract f of x. So I'm subtracting off 2x squared plus 3. All that goes over h. And I forgot to put my limit out here in front of this. But there should be a limit out there. Okay, let's see. Well, now let's go ahead here and do some algebra. Let's see. This is the same as the limit as h approaches 0. Oh, I'm going to multiply all this stuff out. Now, this is x plus h right here. And remember, x plus h squared, that's just x plus h times x plus h. And we would just multiply this out. First ones times outer ones times inner ones times last ones. What that's going to end up giving me is x squared plus 2xh plus h squared. Okay, so I've got 2 times x squared plus 2xh plus h squared. All right, that's just multiplying this out right here. I've got a plus 3 right there. Let's go ahead and put this negative inside these parentheses. So that's minus 2x squared minus 3. All of that goes over h. Let's put this 2 inside these parentheses. So we end up with the limit as h approaches 0, 2x squared plus 4xh plus 2h squared plus 3 minus 2x squared minus 3, and all that goes over h. Now, I think we can see here that we can cancel some stuff out. 2x squared, negative 2x squared, we'll cancel those. 3, negative 3, we'll cancel those. We end up with the limit as h approaches 0, 4xh plus 2h squared over h. Now, if I tried to evaluate this limit, I see I can't do it, right? Because I would get a 0 in the denominator. But remember, we can do algebra, and it doesn't change the value of the limit. If I factor an h out up here in the top, I end up with 4x plus 2h over h. And now these h's cancel out. Well, it looks like I end up with something I can work with now, right? If I take h equals 0, if I can put 0 in place of my h up here, well, this term right here goes away. Looks like I'm left with 4x. So my derivative in this case is 4x. And like I said, I know this was a lot of messy stuff, got a little bit complicated, but this isn't really the way that we're going to do derivatives. We're going to have some shortcut formulas that'll make this a whole lot easier to go through. But what we found is that we've got a function, 2x squared plus 3, and if I want to find the tangent line, the slope of the tangent line, anywhere along this function, the slope of that tangent line would be given by the formula 4x. So in particular, we were asked to evaluate f prime of negative 1. Well, f prime of negative 1, remember f prime is just 4x, so f prime of negative 1 is negative 4. Okay, let's go in here and just kind of get a visual of what that means. I've put 2x squared plus 3 into my calculator here. And let me zoom that in a little bit. Okay, and I'm going to go in here and graph this thing. And I've sort of set up my window so I can get a good view of this. Here's the graph of 2x squared plus 3. At negative 1 over here, looks like if I go up here, well, maybe I can't really see that yet. Let me adjust that view just a little bit here. I want my y to go up a little bit higher. Let's just go up to about 10 or so. Okay. There we go. All right, so here's negative 1. And if I go up here onto this graph, I see that I've got a point right there. And imagine what that tangent line would look like right there. That tangent line would slope downward right there. And what I know is that tangent line right there actually would have a slope of negative 4. And that comes directly from the derivative right here. Okay, so that is just an introduction into the derivative. Again, remember, this is not really the way that we're going to do these things, but we see there's a formula, there's a process for getting to that. And so that when we get to the shortcut formulas, it's going to be so much easier to find these derivatives. And that's what we'll get into in the next lesson.